So, have you ever gone outside and just noticed, seems like it doesn't get as cold as it used to? Or is it me, or are we just not getting as much rain as we used to? Well, how do we know that that may actually be a symptom of climate change? Well, like we talked about last time, you can't use one instance to make a conclusion. However, over the last 150 years, we have been able to take different anomalies and piece them together to really get a good picture of what's actually happening to our planet. So, with that being said, what I'm going to talk about now and for the remainder of this module is how climate science has become what it has today. I'm going to take it in three parts. The first part is going to be late 19th century to mid 20th century. Then we're going to talk about mid 20th century stuff. And then we'll talk about very, very recent stuff. So here we go. Let's first talk about the late 19th century to early 20th centuries. So for us to even know that our Earth is warming up, we need to have accurate temperature records. Well, the bad news is we did not have accurate temperature records until the late 1800s. Um, Accurate temperature records go back to approximately 1880. So pretty much from 1880 on, we have been collecting and analyzing and looking at temperature records. And obviously, as time has gone on, our ability to collect these things have become better and better. But we can actually look back and say, pretty much 1880 onward, we have a pretty good picture. Um, Anything prior to 1880 is determined using what are called proxies. A proxy is basically a substitute. Like if I had somebody else guest lecture for me, they would be my proxy. They would actually be speaking for me and speaking on my authority in our class. So that's what a proxy is. But for today, we're not going to talk about proxies. We'll talk about them in the next module. But that being said, we've been taking accurate records since 1880. A little bit before 1880, the very, very, very first study that ever suggested the possibility of a greenhouse effect was carried out and was published by a woman in the 1800s, which is so cool in my opinion to think that one of the biggest pioneers of climate science was a woman by the name of Eunice Foote. She was also a very high-profile women's rights activist. She was the fourth person on the list of people who participated in the Seneca Falls Women's Rights Convention. So she was a pretty badass pioneer of women in science. And so it's so cool that we can actually trace climate science back to her. Well, her study was the first to suggest that carbon dioxide could lead to warming. And unfortunately, for a lot of reasons, she never really got the recognition that she deserved. So it's really cool to actually be able to bring her up now. And I'll talk about how she got to this conclusion in a few moments, and how you could even do it at home if you wanted to. Now, that being said, she was the first person to suggest that carbon dioxide could have a warming effect. A little less than a century later, a climate scientist by the name of Guy Stewart Callendar used used her conclusion, and used temperature data recorded from all around the world to for the first time, suggest that the increase in carbon dioxide around the world is causing warming. And he published his first study in 1938. He had suggested that there was a substantial rise in global mean surface temperatures from 1880 to 1935. And using Eunice Foote's conclusions, he suggested that carbon dioxide concentrations are going up. We can see that. That was the cause. At the time when his study was published, the United States was going through the Great Depression, was experiencing the Dust Bowl, and we were starting to see the first warning signs that this could actually be happening. Now, unfortunately, 1938 is right before one of the biggest crises in world history, World War II, and so climate science kind of took a backseat to making sure that Nazis didn't take over the world. So, not a whole lot was done with Callendar's study initially. But you will see as time went on, the snowball, or the anti-snowball, I guess, began to build up. So let's talk a little bit about each one of these points really quickly. First off, accurate temperature records. How do we know when we record a temperature that it's accurate? Well, believe it or not, there are only 3 requirements. If you go outside with a thermometer, there are 3 things you need to do with it in order to make sure that it is accurate. And here are the 3 things. You need to place it 1.5 to 2 meters above the ground. I usually tell people if you have a thermometer and you're going outside, putting it up at eye level is a pretty good place to do it. Eye level, if you're standing up, eye level for almost every person in this class will be somewhere between 1.5 to 2 meters. The very, very shortest person might fall very short of eye level of 1.5, and Shaquille O'Neal or The Undertaker might be a little bit above 2 meters. But for most people, eye level is a good gauge for where you should be placing your thermometer. The next thing you need to do is you need to place it in the shade. Believe it or not, you don't want to do it in the sun because sunlight will be absorbed into the thermometer, causing an inaccurately high reading. So you don't want to do that. And then finally, you want it to be protected from elements, from wind, from rain, from annoying meteorology teachers like myself, but you also want to make sure that it is well ventilated. Now, if you're just stepping out for a moment and recording temperature, as long as you're not gripping the bulb, if your hand is maybe at the top of the thermometer and you're holding it with your thumb and your index finger, you're probably okay. But if you're going to have a thermometer out there for longer than just a few moments, you want it to be sheltered. That way, rainfall, that way, humidity, that way, dust, animals, and so on don't get into it and mess up with the reading. But you still want it to be ventilated because you are trying to measure outside temperature. Otherwise, it would be like me standing in my office with the door closed, holding up my thermometer. I'm in an insulated room. I can't get outdoor temperatures inside. That would be inaccurate. Now, all of that being said, these are the first accurate temperature records. And this standard was established by the World Meteorological Organization. There are over 140 member nations around the world, pretty much the entire developed world, and much of the big players in the developing world are members of the WMO. And the WMO says, hey, we all need to do it this way. That way we can accurately compare our data to one another. Otherwise, if we do it one way here in San Jose and our friends in Santa Cruz do it in a completely different way, we can't compare our records. I can't say for certainty, hey, it's warmer in San Jose than it is in Santa Cruz. If the people in Santa Cruz are measuring temperature an inch above the ground, whereas we're measuring it at 1.5 to 2 meters, we can't accurately compare. So we all have to do it the same way. But because we all do it the same way, we can all conclude that, hey, since we're all doing it the same way, we can agree that this data is usable. It can be a part of the record, and we can compare it to other data collected. So that's why we all do it the same way, so that we eliminate other variables that could mess up the data. Now, that being said, so we had temperature records starting in the 1880s. Eunice Foote in the 1850s was the person who devised this amazing experiment, something that you can actually do at home to demonstrate the impacts of carbon dioxide on temperature. Here's what she did. There are a few different tubes, here are a few different flasks um, with different types of air in them. Different flasks with different types of air in them. Actually, these two right here are probably the best example of this. One of these has a bunch of carbon dioxide in it, and another one does not. One has carbon dioxide, one does not. Well, she put them in a window, let them sit out in the sun, soaking up a lot of sunlight, and then she compared the temperature of the air inside both of them. And what she noticed was that the one that was full of carbon dioxide was warmer, the one that wasn't was cooler. You could actually do this at home if you had 2 jars and you filled one of them up with just carbon dioxide. You could exhale carbon dioxide into it. You can find a carbon dioxide source and put it in there, making sure that it is flushed with carbon dioxide. Close the lid, put a thermometer in, then take another jar. I just put regular atmospheric air in, close the lid, make sure you have a thermometer in it as well. Put them both out in the sun. The one with more carbon dioxide is going to have the warmer temperature. That's a cool experiment that you can do. And Eunice Foote was the first person to do that experiment. So in addition to being a badass pioneer of women's rights, a part of the Seneca Falls Convention, Eunice Foote also was one of the first people to suggest, hey, carbon dioxide is something that we should be concerned about. Now, at this time, we didn't really have much evidence that carbon dioxide concentrations were going up and therefore temperatures were going up. That's where Guy Stewart Callendar comes in. In 1935, after having 55 years of global temperature records, Guy Stewart Callendar, looking at different climate zones, the North Temperate Zone, so that's some places in the Northern Hemisphere, the Tropical Zone, that's near the equator, and the South Temperate Zone, so that's places such as South Africa, Southern Brazil, Argentina, Australia. Using each one of these locations, Guy Stewart Callendar was able to actually model a noticeable increase in global temperatures compared to the overall average. And he was able to suggest that the Earth was warming up. And he believed that it was because of an increase in carbon dioxide concentrations. Now, that being said, he published the study right before the advent of World War II. So it kind of took a back seat. Now, after World War II, as we got into the 2040s, oh my gosh, the 1940s and 1950s, a lot more evidence was starting to show up that the Earth was not just warming, but that carbon dioxide concentrations were going up. We'll talk about that next.